Hello, in this video we are going to practice single linkage clustering. The dataset that we have is about colleges and universities, and the question is asking us to do the clustering only on the first 5 schools. When we look at the dataset, we see that we have different orders of magnitude. So in order to find the distance, first we need to normalize our data and find normalized distance. In order to do that, we calculate the z-score for each data point, and then we use those z-scores to find the distance. So basically, we replicate the table and find the z-score for each data point. In order to do that, we use the standardized function equal standardize the value. Then it will ask for the mean. Remember to use absolute referencing because we want to fill the table, and standard deviation. Close parenthesis and enter. So I fill the table and then we continue. Now I have normalized my data. The next step is calculating the distance. So I create a distance matrix for the data points that I'm interested. We are interested in the first 5. So for each pair, I calculate the distance. So the function that we are using is square root of sum xmy2, and then we choose the array that we want to find the distance. We are interested in Amherst, and the distance between Amherst and Bates, Bernard. I will continue with the same manner and find all the other distances in the table, and then we decide which one to merge. Now our distance matrix is complete. The next step is looking at these distances and find the minimum distance, meaning find the closest pair and merge those pair together. So we'll look at this table and we see that 0.7 is the closest distance. So it means that in the next iteration, we will merge Amherst and Bowdoin in one cluster, and then we look at the distance between this cluster and other pairwise data points that we have. So we already have calculated the distances, but when we have a cluster and one data point, how do we find the distance? We look at the minimum distance of these pairs because we are using single linkage. So the single linkage, if you remember, use the minimum distance between different pairs and use that as the distance between that cluster and that data point. So we look at the distance between Amherst and Bernard, this blue cell, and we look at the distance between Bowdoin and Bernard, and the minimum will be the distance here. 2.9 is the minimum. The same manner, we look at the distance between Amherst and Bates, the green one, and Bowdoin and Bates, the green one, and the minimum is 2.06. Same manner, we look at Amherst and Bowdoin, Amherst and Berkeley, this yellow one, and we look at Bowdoin and Berkeley, this yellow one. So the minimum is this one. And I will just copy and paste the other values. Again, we have completed our distance matrix, and we look at the data and find the minimum distance. Here, the minimum distance is 1.8. It means that Bates and Bernard can be merged together in one cluster. So we do that, we merge. We already had one cluster with Amherst and Bowdoin. We create another cluster with Bernard and Bates, and look at the distance. And because it is single linkage, again we look at the minimum. So we look at the Amherst-Boydon cluster and Bernard 2.9, and we look at this cluster and Bates 2.06. So the minimum is 2.06. And for the next one, Amherst, Boydon, and Berkeley, we just copy it. And this one again, we look at Bernard and Berkeley, and we look at Bates and Berkeley, these blue cells, and the minimum is 2.8. So with the same manner, we look at the minimum distance of the table is 2.06. It means that we can merge Bernard, Bates, Amherst, and Boydon into one cluster. So let's do that. We create a cluster that includes 4 universities, and then we look at the distance between these 4 clusters and the Berkeley. So Amherst, Boydon, and Berkeley is 3.8. Bernard, Bates, and Berkeley is 2.8. So the minimum distance is 2.8. So we have created our clusters. So in order to show the visual way of showing how we proceed in clustering, we use dendrogram. And in using dendrogram, we put data points in horizontal axis, and these are the distances. So if you remember, the first one that we merged together was Amherst and Boydon, and their distance was 0.71. And then we merged Bernard and Bates, and their distance was 1.8. The next step, we merged all these 4 together, and their distance was 2.06. If we move even forward and put everything together with Berkeley, we will have this distance 2.8. And if we look at the data, we see that clearly these 4 universities, liberal art colleges, have similar profile, and they're very different with Berkeley. So we see that we could identify the similarities and put them together in a meaningful way.